So here I have two more problems dealing with the conversion between polar and rectangular coordinates. Here, this one here is obviously in polar form. We want to convert this into rectangular form. So obviously know your equations. Know that x is equal to r cosine theta, and then y is equal to r sine theta. Right, so you know these two equations, and then obviously know this is your radius, right? -1 here. Again, in the next lesson I will be going over when you have this concept of -1, right? We know that distance can never be -1. However, this really means that the direction is being switched. So, for instance, you're going towards -3 pi over 4, right? So what this means is that the direction of the direction will really just switch. So I'll just go in more depth later in the next lesson onto this concept here. So we have our two equations for number 87, and so now when we're looking at this, we know that x over here must be equal to, so that's r times cosine theta. Well, r's -1 here, so cosine theta so we have times cosine of -3 pi over 4, comma, well, we have -1 times sine of theta again, right? And here in this case, theta obviously remains the same, -3 pi over 4. So we have this over here. Now when we're looking at this, cosine of a negative angle is equal to cosine of that same positive angle, right? So cosine of 3 pi over 4. Well, cosine of pi over 4 is root 2 over 2. This is in the second quadrant, therefore this must be negative. So we're seeing negative root 2 over 2, and we're multiplying that with a negative value. So our overall x coordinate must be positive, right? So it is root 2 over 2. And our y value here, well, sine of -3 pi over 4, right? It's the same thing as negative sine of 3 pi over 4. Well, sine of 3 pi over 4, that is positive, right? So that is positive root 2 over 2, right? But we have a negative there, so negative root 2 over 2. However, it's being multiplied by -1, so this is also positive root 2 over 2. So clearly this indicates that this is this value over here, right? This is in quadrant 1. Now you may be confused because clearly looking at -3 pi over 4, this does not seem to be in quadrant 1, right? But that's why I said that it's important to understand this concept of -1, which really means your direction is being switched. So now I'll tell you what that means. -3 pi over 4, right? So when we're converting this into degrees, right, we have something like that. So the pi's go away, right? And you have something like -135. So you know that this is -135 degrees. Well, if you start here and you go clockwise, you know this is 90 degrees, and then you want to go 45 more degrees. So that's gonna give you somewhere here, right? This is quadrant 3, right in between quadrant 3. So we're splitting that quadrant 3, right? Because this is 45 degrees. So this is where we are when we say -135 degrees, right? Going clockwise, right? Obviously not counterclockwise because we have a negative angle, so we're going clockwise. So we know this angle over here is 45 degrees. However, we know that we're not in the third quadrant because this point over here, this x comma y, we know this is quadrant 1. Well, we have a -1. This is good because whenever you have a negative radius, right, all that means is that, well, you have a specific angle, and then if you really want to know where you stand, then because of this negative, you want to go in the opposite direction. So the radius is obviously 1 here, right? But what this is really saying is that you want to move in the opposite direction. So your actual point instead of this would be to go in this direction, right? So this is what you're looking at. So your final point, or x comma y, would be here, would be in quadrant 1 because of this negative radius here. And obviously your radius is +1. What the negative is saying is that your direction needs to be reversed or switched. So by switching the direction, we go from quadrant 3 to quadrant 1. So for question number 87, that is our answer, root 2 over 2 comma root 2 over 2. So now I have one more that deals with this type of problem here. So it's question number 88. We have 16 comma 5 pi over 2. Again, we want to convert this into rectangular rectangular system, right? So again, we use that same concept. X is equal to r times cosine theta, right? And then y is equal to r times sine theta. So let's think about this. So we have, we obviously know that the radius here, right, because this is in the form r comma theta. So we know that x is equal to 16 times cosine of 5 pi over 2. And we know that y is equal to 16 times sine of 5 pi over 2. So let's think about this. Cosine of 5 pi over 2, right? Well, you know 4 pi over 2 is 1 revolution. That's 2 pi. So now we want to go pi over 2 more. So this is really saying cosine of pi over 2. Well, cosine of pi over 2 is 0. So therefore this over here is equal to 0. Now looking at this, sine of 5 pi over 2, well again, 4 pi over 2 is 2 pi, that's 1 revolution. We want to go pi over 2 more. Sine of pi over 2 is 1. 1 times 16 is 16. So here, this over here is 0 comma 16, right? And that makes sense. If you do graph 0 comma 16, that's somewhere here, right? Somewhere here, 0 comma 16. And so obviously here, when you look at your angle 5 pi over 2, you know, you're going 4 pi over 2, that's 2 pi, 1 revolution, and then you're doing pi over 2 more. So you will obviously be somewhere along this positive y-axis. So here it would make sense for us to say that, oh, our x comma y point is 0 comma 16. So that's question number 88. Thanks for watching.